Let's consider proving the following very famous inequality. We assume a and b are positive or 0, and a plus b divided by 2 is greater than or equal to square root of a times b. Uh, very common proof by students is the following. So this is kind of wrong proof. Okay, first we multiply both sides by 2, so we have a plus b greater than or equal to 2 square root of ab. Then move the right hand side to the left hand side, we have a plus b minus 2 square root of a b greater than or equal to 0. Then considering a as square root of a to the power of 2, and similarly b is equal to, okay, let's write it down like this, and b is square root of b to the power of 2. And of course, square root of ab is square root of a times square root of b, so therefore we have square root of a minus square root of b squared greater than or equal to 0. And therefore, this is true, right? So this is the proof. And the equality sign holds when a is equal to b. Okay, so this is a kind of wrong. It's not entirely correct, because just by looking just by looking at this proof, we cannot see what you mean by this flow of inequalities. You may mean that if this is true, then this is true, then this is true, then this is true. So in this case, what we have proved is that if this is true, then this is true, right? But that's not what we wanted. We wanted to prove that this is true. But here we are assuming the conclusion. Therefore, this proof is not entirely correct. So what you can do is, instead of just assuming the conclusion, you just cannot assume the conclusion to deduce that conclusion. But there is some situation where you can assume the conclusion. That situation is this. So assume this is true. This is true if and only if this is true. So if you just add this double-sided arrow, then this is okay. And the second inequality is true if and only if this is true, right? So if this is true, this is true. And if this is true, then this is true. If and only if. And this third inequality is true if and only if this fourth inequality is true. Okay? Then all these are equivalent to each other. And the last inequality is trivial because it's a square of some real number, right? So if this is true, then this is true, because it's everything is connected by if and only if. So if you just write these double-headed arrows, then this proof is correct. Okay, but if you don't write anything like this, then just by looking at this, sort of proof, I cannot judge whether you really understand what you're doing or not. So please be explicit about what you mean. Okay, so if you write these arrows, double-headed arrows, then this is just fine. But if you don't, maybe you won't get the full marks. Okay. Alternatively, you can use this logic as just an experiment. You just ignore these. Consider this. What if this is true? Then this should be true, and this should be true, and this should be true. So based on this, you can write the following proof. For any for any a, b positive or 0, we have a square root of a minus square root of b squared is greater than or equal to 0. So this is true. From this, by expanding this, we have a plus b minus square root of a square root of b greater than 0. Therefore, okay? Therefore, by moving this to the right-hand side and dividing both sides by 2, we have this, the final conclusion. So we are done. So this is just fine because we started from something trivial, then draw this conclusion. So we did prove this inequality from something more trivial. So this is just fine, sound logic. But assuming the conclusion is not sound logic, usually, unless you connect them by equivalent statements like this. Okay. And of course, the equality holds if and only if a and b are equal. And so in this case, a minus b squared is equal to 0 if and only if a is equal to b. Therefore, a plus b divided by 2 is equal to square root of ab if and only if a is equal to